Hello, I'm Ashish, and in this video, I'm going to solve the first question of our maths intermediate assessment. So, as given the question, let us take y as the amount of fresh air at any time t. Okay. So now what we have here is we need to find the rate of change, time rate of change, sorry. We need to find the time rate of change, which is dy by dt, which can be written as the inflow of fresh air minus the outflow of mixed air. Okay, yeah. So now the inflow of fresh air, the inflow rate. Okay, so the inflow rate is given as 600, and the outflow rate of the mixed air can be taken as 600 divided by 20,000 into y, and this is y dash. So now if I rearrange this, we can take it as y dash plus 600 by 20,000 into y equals 600. Now this is a non-homogeneous linear ODE. Now comparing this with the general equation, which is fy dash plus fp of x y equals r of x. This is nothing but a non-homogeneous ODE, linear ODE. Okay. Now here Rf is 1, p of x is 0.03, and r of x is 600. So from this we can find our integrating factor, which is integration of p of dx, which is integration of 0.03 dx equals 0.03x. Now from this we can find e power h, which is e power 0.03x, and e power minus h would be e power minus 0.03x, and r into e power h would be 600 into e power 0.03x. Okay, now the general solution is y of x equals e power minus h into c plus integration of e power h into r dt. Okay, so now r e power, or dx or dt, whatever we can take it as, we'll take it as x. Now r e power minus h is this plus into c plus r can be taken outside into integration of e power 0.03x dx. Now this part will go down and be normal e power x when we integrate this. So again e power minus 0.03x into c plus, now when we do 600 divided by 0.03, we get 20,000 into e power 0.03x. Okay, this is our y of x. Now using the initial conditions, which is given as y of 0 equals 0, so when you put x is 0, we get a 0 equals, this will become 1, so c plus this also will become 1, this term, so we can take this as 20,000. So here our c is minus 20,000. Now when I put this minus 20,000 in the normal equation over here, I'll get y of x equals minus 20,000 into e power minus 0.03x plus 20,000 into e power 0.03x. Okay, yeah. So now we can now to get, now for 90% of fresh air to be present in the room, we need y as 90 by 100 into 20,000 is equal to 18,000. If you cut this like this, you get 18,000. So now I'll put this value over here, then we'll get again 18,000 equals, oh wait a minute, I think I did a mistake here. What happens here is this will become again into minus 0.03x, so this term will become 1. So our y of x is basically 20,000 into, I mean, minus 20,000 to e power minus 0.03x. Sorry for the mistake, I did that, can correct it here. Now if I put 18,000 over here, which is the y of x, so 18,000 equals 20,000, I'll take it common, 1 minus e power 0 minus 0.03x. Now I do this 209, 210, and 0.9 equals 1 minus e power 0.03x. Okay, now rearrange it, we get here 0.1. Now I'm taking ln on both the sides, so I'll have minus 0.03x equals ln of 0.1. Ln of 0.1 is 2.3, and I mean minus 2.3 and minus 0.03x. So x would be, when we divide these two, we get 76.66 the bar. So we can approximate it to 77. So thus time taken is 77 minutes for 90% of fresh air to be present in room. Thank you.